Okay, are we ready to talk about area and volume? We have low volume and high volume. All right, so the first question here is refer to figure 57, which is this one. It says determine the area of a triangle formed by points A to B and C to A. A to B and C, what? A, B?
Yeah.
A to B and C to A. A to B and C to A. Top triangle. There we go. Determine the area of the triangle formed by A to B. Oh, there it is right there. If B equals 7.5, if A to B equals 7.5 inches, and A to D is 16.8. Well, guess what? It's 16.8 up there too, inches. So how hard is this one? This is super simple. What are we going to do?
Multiply 7.5 by 16.8 first.
Multiply 7.5 by 16.8 and then
Divide by 2.
times 16.8 and then divide the whole thing by 2 and we get
63 square inches.
63 inches squared, or you could do SQ, that's a Q, SQ, inches, or something. Don't put 63. If you put 63, you got it wrong. All right. Well, that one's a little blurry up there. Figure 55, find the area of the triangle as shown. Now what are you going to do? Same thing. Formula is width times length divided by 2. So what is my width, I guess? 4 times 3 divided by 2. So we get 4 times 3 is 12 divided by 2 equals 6 inches squared. Okay. Maybe we should have started. Now I'm feeling good. I think, I always want to evaluate, how I'm doing as an instructor. And I feel that if nothing else, we've kind of gotten this one down. That is a square and that is a rectangle. Okay. All right. Holy crap, I didn't know that was on there. I think I missed one here. Let me see. We got 55, 57. Yeah, I kind of missed one here. Let's see. I've got. Oh, hang on. Go back to that. Maybe it's the next one. Yeah. Okay. Nope. I have one that's similar. Let me see. There we go. That's what I was looking for. I'm out of order here. 54. I do want 54. 54. Compute the area of the trapezoid. Well, what are we going to do about trapezoids?
Solve for the...
All right. The formula is the average of the length of the parallel sides times the height. So the average of the length, average of the length of the parallel sides, average of the length of parallel sides times height times h. So, all right, the average, what are my parallel sides? Parallel means that they are not the sides. Parallel means they're parallel. That is not parallel. This is parallel. That's parallel. So parallel sides are 9 and 12. So to find the average, it's 9 plus 12 equals 21. And then we divide by the number of things that we just added, which was 2. So divided by 2. So 10.5. So divided by 2 equals 10.5. So we take 10.5, average length of the parallel sides, times
5.
the height, which is 5. So the area is 52.5
Square feet.
feet square. Why is it feet square?
Because it's one apostrophe.
Because it only has one apostrophe. So sometimes I don't say things like that. Somebody will go, oh, I didn't know that. So it's okay if you don't know that. 54, 56. 56. All right, now that we know how to do it, it is 6 plus 4 equals 10 divided by 2. So the average of the parallel sides is 5 times the height, which is 10
Feet squared.
feet squared. Square feet, feet squared. All right, let me see. All right, this one actually caught me by surprise. I didn't realize this was even in here. I'm like, oh, did you ask you to do what? I used to do this in my just regular notes. I'm like, I'll never ask you to do the volume of a sphere. Who would ask that? But apparently they do. Problem gives the formula, so all you have to do, let me see, refer to figure 71. Let me see, what is the volume of a sphere with a radius of 4.5 inches? So a sphere, that's a two-dimensional sphere, with a radius, that's the radius, of 4.5 inches, 4.5 inches. So we just plug in the formula. So volume equals,
What's the radius?
4.5.
1/6 pi, or 1/6, I just wrote half, 1/6 pi times the diameter. What's the diameter? 9 cubed. See if you can do that one. Make that stop. Volume equals 1/6 pi diameter cube, so its volume equals 1/6 pi 9. Okay, so volume equals 1/6 pi 729.
Yeah.
All right. Oh yeah, it says that right in front of me. So 1 ABC 6 times pi times 729 equals, and you get
381.70.
381.7 watts.
Cubic inches.
Cubic inches. All right. Let me see. Sometimes these are fun. What is the surface area? Oh, this is a great one to work with. What is the surface area of a cube? Let's see if I can draw a cube. Cube should kind of look like that. Let's see. Surface area of a cube. There we go. Oh, not bad. Okay. Where a side edge measures 7.25 inches. 7.25 inches. All right, well then what's the height? 7.25 inches, and what is the width?
7.25 inches.
That's the cube. So what do we do?
Multiply 7.25 by 7.25.
So we want the surface area.
7.25 by 7.25.
So I would figure out just what is one side of this die right here. So 7.25 times 7.25 equals 7.25 squared. 52.5625. So that is the surface area if this was a die, like a dice, but just one, and this was like had the one. That would mean that always equals 7. What is a die? Opposite sides always equal 7. Yeah, okay, so the other side 6. Anyway, so the surface area of one of that is 52.56. How many surface areas do we have? 6. So we multiply that by
6.
Okay. So we get 375 to be exact if you didn't actually round out your calculator. So there we go. But this brings up a good point right now, I think. I don't have it in my notes. If I have a two-dimensional item, and this is 1 foot by 1 foot, how many cubic feet do I have? Or how many square feet? Square foot. I have 1. How many square inches do I have?
144 square inches.
144. Or we could look at it this way and say, that may not work out. Don't worry about that then. What if we had 3 feet by 3 feet?
9 square feet.
Okay, so we have 9 square feet. If I had 1 yard by 1 yard, how many? Let's do 3. 3 yards by 3 yards. How many square yards do I have?
9
Okay, I have 9 square yards. Square yard. If I want to convert that to square feet, what do I do?
Multiply each side length or by 3.
I don't want to do that. It's just 9. I think I'm going backwards on this. I didn't write down a good example. What was a?
You square that in, sir.
Yeah, I know how to do it. I was trying to think of a really good example where maybe we should just go to this wing one we had. Let's do that. All right, so we have a wing, and I don't remember what it is exactly, but we're going to cover a wing with fabric. Everybody's already done this now, I think, and turned it in. Some of you are like, I don't know what the hell happened. I just looked at the guy next to me. And we have a wing, let's just say it's, what do we want, 15 feet by 4 feet. That's our wing. And we need to know how much fabric we need. All right, and so what is my square feet right there of that wing, that surface?
60 square feet.
60 feet square. But that's just one side. And how many sides do I have to deal with?
You have 4.
4, because you have the top skin, then the bottom skin, then the top skin, then the bottom skin. So times 4. So how many square feet do I have?
240.
240 feet square. All right. Except fabric doesn't come that way. It comes, say it comes by the yard, I think was the question. And so how many square yards do we need? Well, actually, I made it worse. I think I gave it to you in inches or something like that.
Converted it from.
Yeah, I gave you some crazy thing. Oh, we should do that, huh? Just really have some fun with
It was
this.
11 feet 2 inches by.
Okay, well, let's. All right, throw it out. What was it?
I think it was 11, 3, and 5, 4.
Oh, that'd be fun. 11. Okay, close enough. 11 feet. What? 5 inches?
3, 3.
I know, but I'm changing it. And what was the width?
5, 4.
5 feet 4. That's a fat wing. No, that's actually all right. Okay, so 5 feet. We'll keep that. 5 feet 4 inches. All right, so 11 feet 5 inches, 5 feet 4 inches. The worst thing you could do right now is call it 5.4 feet. But if we convert it to inches, how many inches is that?
64.
Let's say 5 times, right here, 64.
100 and, yeah, that's
64 inches and 11.5, so it's 11
137.
times 12 equals 132 plus 5, so 137 inches. All right, so 137 times 64 equals
8,768.
8,768 inches squared. That's one surface area, but we have 4 surface areas. So we multiply that by 4. Okay, what do you get?
35,072 square inches.
35,000.
72.
Or 7.
072.
Thank you. 072. It's much easier to hear it that way. 35072. Okay, we have 35072 inches squared. All right, well, how many square feet is that? Well, everybody knows there's 12 inches to a foot, right? So divide by 12?
No. Divided by 144.
144. Why would I do 144?
Square inches.
Because a square inch is 12 inches by 12 inches. There are 144 of these little inches and little squares in there. There's 12 up, 12 down, that's 144. So if I want to convert that to square feet, I would have to divide by 144, which equals
243.6 square feet.
feet square. What if I want to convert this to yards? There's 3 feet in a yard.
Divided by 9.
Divide by 9. Well, wait a minute, there's only 3 feet in a yard.
36 squared for inches to yards.
Say that again.
36 squared for
if we
inches
were
to
to-
yard.
Okay, so let's look at it down here. So if I'm going from feet, so a yard, that's 1 yard, is 3 feet. So 1, 2, 3. 1, 2, 3. So there are 9. Geez, what about inches?
1296.
That's a lot. So if I want to go from inches of that. So all right, we can convert feet to yards. We divide by 9 because there's 9 squares in here. 3, 4, 5, 6, 7, 8, 9. So we divide by 9. We get
27.1 square yards.
27.1 yards square. That wasn't so hard. What's the secret? Secret is don't divide by 12 and don't divide by 3.
Knowing your conversion rate.
Knowing your conversion rates. And that's why we go back to when I talked about in 309. I would want to convert it to yards if you can. It's a little hard to do. You know, you could really screw up doing 11 feet, 5 inches into yards, I think. Could you?
I would go to inches and then take it from inches to yards.
Yeah, me too. Yep. That would work. Because there's how many inches in a yard?
36.
There we go. So we can do 137 divided by 36. We get a decimal. That's a good point. So just make sure that you're converting at the right time and that you are not converting using 12 or 3 because it's not linear, it's square. All right. Did the surface area. All right. A rectangular shaped fuel tank. Well, that's annoying. What's worse is I think I answered it. Probably still is. Thanks. We'll just edit that part out. All right. Let's see. Rectangular fuel tank. Rectangular fuel tank. You guys remember what a rectangle is, right? Okay. There we go. We don't have to draw the whole thing. All right. That's close enough. Let's see. Rectangular shaped fuel tank measures 60 inches, and it doesn't matter where you put it. I could put the 60 here, here, or here. But it measures 60 inches in length, 30 inches in width, 30 and 12 inches deep. So 12 inches deep. How many cubic feet are within the tank? Well, it just gave it to me in inches. And it's asking me how many feet are in the tank.
Convert to feet.
You want to convert to feet? I would. So that changes it to, put it in red. 1.
That's 2.5 for the 30 inch.
Okay, 2.5. So how did we get that? Just 30 divided by 12, right?
Yes.
Okay, 30 divided by 12 equals 2.5
5.
and 5 feet. So we've got 5 times 2.5. 12.5. Because it's, I'm sorry, I should do the whole thing. This should be fatter. Let's see. To do it correctly, we would have did 5 times the 2.5 times 1 equals 12.5. Well, if you didn't want to do it that way, let me see, you would have ended up with 1,728, I think, 30 times 60 times 12. 30 times 60 times 12 equals, I think 30 times 60.
25,920.
When did I? What'd you say?
21,600.
Yeah, I keep getting 21.6.
You know, something we got.
So you'd get, oh, this, see, I don't like doing it this way. 21,600 inches. Now we got to convert to feet. So how many cubic inches are in a cubic foot?
144.
No.
No,
17.8
times
1296.
times 12.
Because it's 12 times 12 times 12.
Yeah.
1728.
So that's 12 times 12 times 12. See how easy it is to screw up?
Yeah, that's super easy.
Yeah. So that's 12 times 12 times 12 equals 1,728. So you have to divide that by 1,728. And you end up with, oh, thank God. Okay, 12.5. 12.5. So there's two ways, well, there's many ways to go. I would not do that. I would absolutely do it this way.
What's the conversion rate of the volume of gasoline? So like if we were then asked how many
Oh, they're going to tell you in just a minute.
All right.
They always give you that. You never have to memorize it. Let me see. Yep. Very similar question. Rectangular fuel tank measures 37 and a half in length, 14 inches in width, and 8 1/4, that's 8.25, inches depth. How many cubic inches are in the tank? So I gave it inches, 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 and how many cubic inches? That's not hard. Everything's already there for you, and I just converted it to a decimal. But if I didn't, you could have used the fraction decimal key or the ABC key. How much?
404.25.
No, I don't think so.
Wait, you talking about what?
It's 4,331.25.
Oh, I missed the 7 in there. Whoops.
4331.25 is what I had written down. So yes, that's an easy one, right? All right, a little more complicated. A rectangular shaped fuel tank measures 27.5 inches in length. Oh, I better draw this one out. All right. 27.5 inches in length. 3/4 of a foot in width and 8 1/4 inches deep. How many gallons will the tank contain? By the way, 231 cubic inches equals 1 gallon. So what do you want to do with this information? You want to go inches? I would. Why? Because it's saying right there, inches. So we have 8 and make sure I did it. Yeah, this is inches up here because I didn't write it very nice. Inches. So all we have to do is convert this to inches. So what is 3/4 foot in inches? So that is 12 times 3/4 equals 9 inches. All right, so what is my total cubic inch of this thing?
2,041.875.
2,041.875. I'm sorry, could you be more specific? 2,041.875, he says, inches cubed. All right. So what am I going to do with this information? For every 231 cubic inches, you get 1 gallon. So am I going to multiply this by 231? We are not. We want to see how many 231s are in there. How many 231s are in there? So we're going to divide by 231, and we get what?
8.84. How did we get 2,041.875?
Let's back up a little bit. How did we get 2,041.875?
Yeah.
All right, that's my fault. 27.5 times 9 times 8.5.
That's
It-
2001.
Oops, did I do something wrong?
I think you said 8.25 originally, but you wrote 8.5.
Yeah.
Oh.
Caught that too.
Sorry,
Oh, I was working on 8.5. That's fine.
I may have. Let me see. Let me go back. My bad.
I have 9 to get 3/4 of a
Oh.
foot, not 3/4 of an inch.
It was 8.25. Sorry,
Okay.
it was actually 8.25.
That's why I got.
8.25. 8.25.
Now that 8.84 should be
Okay, yeah, that
8.84 gallons.
that works out.
All right, did that come up with 204.1875?
Yes, correct.
Okay. Sorry. Divided by 231 equals 8 point what? 839 gallons. 8.839. Rounded to second decimal.
8.4.
8.84. Okay. Let's try that again without me screwing it up. How many gallons of fuel would be contained in a rectangular shaped fuel tank which measures 2 feet? Measures 2 feet in width, 2 feet in width, 3 feet in length. I screwed up the drawing, but that doesn't matter. And 1 foot 8 inches deep. 1 foot 8 inches deep. Note, 7.5 gallons equals 1 cubic foot. So what are we going to convert to? Feet. I want everything in feet. So what is 1 foot 8 inches? Oh, it's just 1.8, right?
No.
No, it is not.
1 and
So I do 8 divided by 12 is 0.66666. So I'm just going to call that 1.67. So 2 times 3 times 1.67 equals
10.2. 02.
what'd you end up with?
10.02.
10.0. Okay, 10.02. What are we going to call that? Just call it 10. 10 gallons. I'm sorry. Nope. Not 10. Definitely not 10 gallons. 10 cubic feet. All right. So now the question is 7.5 gallons is 1 cubic foot. So for every cubic foot I have, I must have.
7.5 gallons.
So what are we going to do with this information?
Multiply by
7.5. So, how many gallons do we have?
75 gallons.
75 gallons.
How much fuel can you think of?
My plane? 80 gallons. All right, quarts. I was trying to be cool. I don't know if I wrote all this. Select the container size that will be equal to a volume of 60 gallons of fuel. Now, select a container size that will be equal in volume to 60 gallons of fuel. 7.5 gallons equals 1 cubic foot. That is part of the question. You don't have to memorize that. So what do we do there?
Divided by 7.5.
So, okay, let's think this through here. We need a container that holds 60 gallons of fuel, right? And so for every cubic foot, we have 7.5. So we need to hold 7.5. So we're going to do what?
Divide by 6.
Yeah, how many?
By 7.5.
How many 7.5s are in that 60?
8.
8. So we can divide that by 7.5, and we get 8. So we need a container that is 8 cubic feet. And we can check our work. 8 cubic feet times 7.5 equals 60, so it checks out. All right, something a little bit different. Oh, this one, I think question's terrible. Maybe not. There's one of them I hate. It's like, what size sheet metal is required to fabricate a cylinder 20 inches long and 8 inches in diameter? All right, so we're going to be making a cylinder out of sheet metal. It's got a little split down it. So obviously it's a flat piece of something, and we're going to roll it until we get a cylinder that's got a diameter of 8 inches and it's 20 inches high.
Are we capping both ends as well?
No.
Okay.
Nope. So to do this, and I suggest as best you can, memorize the formula. First of all, area equals pi times the radius square. And then we don't want the area of a circle, do we?
No.
What do we need?
The circumference.
We need to know how to make this red pin work mostly. We need to know the distance from here around. And that's called the circumference. So circumference equals,
Diameter times pi.
yeah, you just screwed me up. Pi diameter is what I say, right? Pi diameter or pi times
2 pi I.
2 pi I. Yeah, 2 pi I.
R.
Yeah, I would say 2 pi radius. The radius times 2. I always just do pi diameter because I can remember that. That should be on me. So, all right. So pi diameter. So we're going to start with that and figure out what this dimension needs to be this way to roll it. And to do that, what was my question again? Okay. So first we're going to compute the circumference. So we have a diameter of 8, so it is circumference equals pi times 8. And so the circumference is 25.133 is what I hear, inches, okay? Inches. So it's going to be that. And how tall will it be?
20 inches.
Be 20 inches tall. They just told you that. So 25.33 times 20. Let me see. I didn't write down what the answer choices were. I want to say one of them was a little harsh. 22. Oh, wait a minute. 20. There it is. That's what I did write it down. Sorry. I was just looking at the wrong page. All right. Then it gives you the answers. Let's see. This says all the answers fraction. I didn't write down the answers. They're not good.
5 and 5, 30 seconds, and then 25 and 9,
Yeah. Okay. I've got.
and 20.9.
What's that?
I said it was 25 and 5, 30 seconds,
Yeah, that sounds good.
and then 25 and 9 64ths,
I don't think so because they're all 25s and we had one that's 20.
and then 24 and 9 64ths.
Oh, that's right. And how much?
I think it was 9 64ths as well.
Nice. That sounds right. 964. Sorry. All right. So let me see. Yeah. So which one would be the closest? Well, that kind of sucks. All the answers are fractions. Convert 25.13 to a fraction that is either in 64ths or 30 seconds. So we're going to convert this to either 64 or 30 seconds. So really, we've got the 25 down. So if this is true, then we can probably eliminate that because the circumference is 25. 24 is going to be too short. So now it's either 5 30 seconds or 9 64ths. Well, my decimal over there is 0.133. How am I going to convert that to a fraction?
Divide by 64 or divide by 32.
Not divide.
Multiply.
So we'll multiply by 32. So 0.133 times 32 is 4.256 30 seconds. So 4.256 30 seconds, or times 64, 8.512 64ths. let me see. Is this more or less?
Less.
So it's going to be 2. But this one is also,
Less, but that would be like a round down versus the 8.5 you could technically argue round up.
can't really round when you're working with sheet metal. You can, it's either, I think maybe the answers that we have here, I didn't write them all down. What are my notes? Let me see. Equals I got 8.3264, which must be rounded to 9/64. Yeah, you can't short yourself sheet metal by rounding down. Therefore, 25 and 9/64, I said was the right answer.
You always want more than,
Yeah, you always want a little bit more.
you can always trim.
Oh, I'm sorry. This is the
5/32.
this is the sheet metal you're gonna get. This is what you have to have. That's your circumference. So 9/64 is a little bit more, so you can have a little bit left over.
9/64 is a little more than 5/32.
9/64 is a little more than 8.564. And then let me see. Then I'm just
I'm
making a
a
note
little
here.
lost on that, so I'm not gonna lie.
Answers. Hang on. Let me back up a little bit.
bit less than
Let me,
What's
25
this?
and
8.5/32. 9/64 is.
all right, hang on. Everybody stick with me here. So the answers they're giving you, thank you, are 25 and 5/32 by 20, right? By 20 because it's 20 tall. 25 and 9/64 by 20. Or 24 and 9/64. 24 and 9/64. These are all the answers that they're going to give me. We determined that the circumference is, that's where you would tell me the 25.13. 25.13. That's the circumference. So I go and I say, hey, I need a piece of sheet metal that's 25.13 inches wide by 20 tall. Right? By 20. We're not concerned with the 20 because they give me all the 20s. But I got to have this 25.13. And then the book says, well, I don't have 25.13, but I got 25 and 5/32. I got 25 and 9/64 and 24 and 9/64. Which one do you want?
9.
So if I multiply this 0.13, I'm going to take the 25 and just come over here and go, okay, I got 25. This one has 25, that one has 25, that one has 24. If I get a piece of sheet metal that's 24 and I need one that's 25, that means this is too
Small.
all right, so I don't want that one, it's too small. Well, now we're left with this one. I just said, give me the biggest one, I'll figure it out. But they don't give me that option. So we take this, I want to move this into 64ths. What is this 25/13? I want to create a fraction out of it. So I'll leave the 25. How do I create this 0.13 into a fraction? It's in 64s. Multiply it by 64. So 0.13 times 64 equals 8.3264. So I got 25. I need the circumference is 25 and 8.3264. A stupid number, but that's what it is. That is exactly how much sheet metal I need. Now, which one of those is going to work best for me? Well, I don't know. Crap, this one over here is in 30 seconds, so might as
10/64.
so I know this is going to double it, but yeah. Well, you could just go 10. It's 10/64. Or we can. I like that better. 10/64. So we can convert that. So 25. Do you want 25 and 10/64, or do you want 25 and 9/64? Well, the funny thing is, they're both bigger. I told you I hated this question because it's like I think I always pick the wrong one. Yeah. Well, you're going to get so 9/64. Well, I need one that is 8.3264. See, to me that works and that works. And I think I have this problem every time I do this. Let me see.
If you want to be closer to it,
Yeah, you would want less waste.
All right, but there is no such thing as that. So we have 25 and 8/32. Let's round it to the nearest 64th that's going to work. So how would I round 8.3264? Would you go 25, does it 8/64 or 9/64? Which way would you round?
8, 9, 6.
This time you can't use rounding rules because we're literally working with a physical thing. And if we round down properly and go, well, the 3 is less than 5, so we leave it, it's 8, you're going to be short sheet metal. So now you got to round up and file it. That's how it really works in real life. So that becomes 25 and 9/64 because you round up a little bit. Follow? You can't short yourself. All right. Is it with me?
Yeah, I get it. There was just a lot.
Alright.
Yeah.
So, like I said, I would have said, just give me the biggest piece and I'll figure it out. But no, the answer is 25 and 9/64 because we just round up a tiny bit and file it. If you pick the 25 and 5/32, which is also 10/64, you have to file more, and I don't think they want you to do that. So, yeah, 25 and 9/64 is a good answer. There's also a possibility. Okay, I did write it, but the other one is 5/32, which is 10/64, which is 1/64 of an inch.
Too big.
Too big. And if you are that good at sheet metal, then
I know, that's what I'm thinking.
you are way better than me.
I'm like, who the hell?
All right. What force? Told you that was the worst question in the whole thing.
There's an easier way to solve that, I think.
Yeah, how would you do it?
So if you turn it into an improper fraction and then divide it by the 32.
Wait, you can't say it. Turn what into an improper fraction?
Turn 25 and 9/64 into an improper fraction.
25 and 9/64 into an improper fraction.
And then divide it by 64, you would get 25.14. And then if you take 25 and 5/32 and turn that into an improper fraction, you get 25.15. So then if you were wanting to go just a hair above 25.13, that would be the 25 and 9/64.
I'm sure you're right. I would never remember to do that. I'm always looking for what I can remember when I'm in the thick of it. Yeah. What force is exerted on the piston in a hydraulic cylinder if the area of the piston, so piston area, I'm not going to write out piston area is 1.2 square inches squared, and the fluid pressure is 850 psi. So you haven't had really fluid dynamics, but it's not a hard one. First of all, we figure out, what does psi mean? Pounds per square inch. So we have psi. There's also PSIG, which is pounds per square inch gauge, is what they call it. So it shows up on the gauge. There's PEPSI, which is, that's Pepsi. So that's just okay, we're not doing that. So, all right. So we have 850 pounds per square inch. So for every square inch you have 850 pounds per square inch. I remember when I was a kid, my uncle was this incredible welder, and they'd asked him to weld like some pontoons on a pontoon boat. And I don't know, he was an incredible welder, but maybe not a great mathematician. And I remember going over the house and talking to my dad, and he goes, well, how'd the weld go? Well, I kind of blew up the hole. Well, what'd you do? Well, I wanted to pressurize it, so I figured I'd put, 20 psi. 20 is not a lot. That's 20 pounds for every single square inch on this entire hole, which is, in fact, we'll do this one next. It's a good story. Okay.
Multiply 850 by 1.2.
So the piston area is 1.2 inches. And how many? So if it's 1.2 inches and there's 850 on every single one of those inches, it is
850 times 1.2.
1.2 times 850 equals 1020 pounds of force. This is not on my list, but so you have a 55-gallon barrel drum. Somebody help me out. What's the diameter of a 55-gallon barrel drum?
2.5 feet.
You think it's about 2.5 feet?
It's like 2 feet.
Yeah.
2.5 feet. So that'd be 30 inches?
30 inches.
About 30 inches? Okay. 30 inches across. So when I went to work for this aircraft place, we had to defuel an aircraft. And so they got a 55-gallon barrel drum, and they defueled the aircraft, put all the fuel in it. And it's a high-wing aircraft. I think it was like an Eagle, not a Kristen Eagle, but a little biplane, sport plane. It was a crop duster Eagle that had a wingspan that's just freaking enormous. I mean, it just barely fit in our hangar. Anyway, and it's tall wings. And so you're not supposed to reuse fuel that you've defueled anyway, unless you've got a lot of filters and stuff. But this place did it. So we got this 55-gallon barrel fuel, and we've got to get the fuel way back up here on this wing up here, a little hole up there. And so the way they did it, the nice way to do it would be one of those cranks. But they didn't do it that way. They did it the way, actually, I did this in the Navy. We used, it's a long story, but anyway, they used what are these holes called?
Bungs.
Bung holes. So I'm not making that. I just wanted somebody else to say it. So the pipe goes down the large bung hole all the way down to the bottom, and then take the hose and we run it up there to fuel the airplane. Well, it's way up there, and so you need a ladder to get up there, but you don't need a ladder because what's right there? Just you stand right here. So
I'm gonna take 2 guys on a ladder and.
So right there, so stand there. Well, how do you get the fuel out of there?
Pressurize it.
Pressurize it.
Oh my God.
Yeah.
So they pressurize it, and of course, when you pressurize a 55-gallon barrel, what do you hear? Boop! You're a couple inches taller, and now the thing bows out. And here's Danny up here, standing up here. I said, "Are you sure this is a good idea?" I don't know what we had in there. Let's just say we had 80 psi. I said, "You sure you want to stand up there?" Well,
fine.
yeah. I weigh standard aviation guy who's shorter than I weigh. He weighs 170 pounds, and there's only 80 pounds on it. So it's what's the big deal? So if the area is pi times and I did this right in front of him. Let me show you why I wouldn't do that. Area is pi r squared. The area then equals pi, the radius squared. So the radius would be what, 15 squared. So help me out here. So 15 squared times pi equals.
706.86.
All right, so the area is 706 square inches times 80.
A little bit.
PSI is a lot.
That's shop air. I
56,540.
think that's normal shop air pressure, right?
115 and
Right.
120 is shop air.
But that's like maximum, though. I mean, it takes a minute to get up there. I don't know how long it would take.
I don't remember what the pressure was. That probably wasn't that much, but even if it was half that, even if it was only like 20 pounds, say it was 20 pounds on there. What's 706 times 20 equals?
56,480.
Well, 706 times 20 is 14,120. Are you sure you want to stand up there?
You want to go skydiving, that's right.
So.
So,
Oh, by the way, I mean, if I'm going to do this story, I guess I got to do. Where's my pen? To do this story, I got to finish the story, and then it's not break time, man. I'm fine. Danny was a smoker. Always had one. So you are standing on 55 gallons of 100 low lead with 14,000. I don't remember how many psi. It must have been. It ended up being I remember it being a lot, and he like a little white, and he got off the can. He's like, how come nobody told me that? So, good guy. That's why it's good to know how to figure out compute area. When people do that, standing on the barrel.